Okay, today we're going to learn about synthetic division, which is a lot like long division, except it's a more simpler form, and I think a little bit easier to do. Not so much writing. Okay, so we're going to take the polynomial 3x to the fourth minus 2x squared plus x minus 1 and divide it by x minus 1. We're trying to find out if x minus 1 is a factor of the polynomial in the numerator. So we're going to change our factor into a root, and that mean of course, then that the root would be 1. And then we're going to draw an upside down division bar. Our next step is to put in the leading the coefficients of each of the terms. So we have our 3 for the 3x to the fourth. But if you notice, we are missing an x to the third. So we put a placeholder of 0 in. And then we put our -2, a +1, and then our constant -1. Our first step is to bring down the 3. Now, a lot of you say, well, why do we do that? If you want to know why synthetic division works, you can look on Khan Academy. He has a whole video on it. Or you can just let me go through the procedure and learn how to do the procedure, which is probably a lot easier. So we bring down our 3, and then we're going to multiply our 3 times 1 and bring it under the next term. We add down, so we get 0 plus 3 is 3. Then we multiply that 3 again by the 1, and we get 3. We add down, we get +1. 1 times 1 gives us 1. Add down, we get 2. Add down, and we multiply the 2 times the 1, and gives us +1. Because we have actually divided by x minus 1, the exponential value is going to decrease by 1. So this is going to give us an x to the third plus x squared plus x plus 2. And then finally, the 1 at the end is actually going to be a remainder, so we have to have 1 over x minus 1. This is our depressed polynomial. The 1 over x minus 1 is our remainder. Because our remainder is not 0, then we know that x minus 1 is not a factor of the polynomial in the numerator. Okay, here's another example. Taking 2x to the third plus x squared minus 13x plus 6, and we're going to divide that by x minus 2. Because we're dividing by x minus 2, our root would be 2, and then we draw our synthetic division bar, and we put in our coefficients of each of the terms. So we have 2, 1, -13, and +6. Again, we bring down our first term, getting 2, and 2 times 2 would give us 4. We add down and we get 5. 5 times 2 gives us 10. We add down and we get -3. -3 times 2 gives us -6. And when we add those, we get 0. Since we have a remainder of 0, we know that x minus 2 is a factor of the polynomial. Now, I also noticed that perhaps we can take this one step further. So we're going to go ahead and try to divide again. Notice -3 is the constant term now, because the first term is at x squared plus 5x minus 3. So we could use the rational root theorem to come up with our possible roots. So there would be 3 halves, 3 over 1, 1 over 2, and 1 over 1. And so you can pick any of those to use. I'm going to choose -3. And I'm going to go ahead and do my synthetic division one more time. So I'm going to bring down my 2. 2 times -3 is -6. 5 and -6 is -1. 1 times -3 is +3, which gives me another 0. This tells me that x plus 3 is also a factor. So since this was an x to the third, this is an x squared, the final term is going to be an x. So my three factors are 2x minus 1, x plus 3, and which comes from the minus 3 that we negative 3 that we divided by, and x minus 2, which comes from the initial division. If you multiply these three factors together, you would get the first polynomial. Now, looking at each of these, we can get the roots. The roots are x equals 1/2, x equals negative 3, and x equals 2. The fundamental theorem of algebra says that we have to have 3 roots because the highest the degree, the highest exponent is cubed, so there'll be 3 roots. We can also use it for something simple like x cubed minus 8 divided by x minus 2. So we bring our 2, which would be our root, and then we put our division bar, and now we're going to have to write the coefficients. So it's 1x cubed, 0x squared, 0x, and then a negative 8. We bring down our first term, 1. 1 times 2 is 2. 0 and 2 gives me 2. 2 times 2 is 4. 0 and 4 added together gives me 4. And 4 times 2 gives me positive 8, which gives us a remainder of 0. Because the initial polynomial was x cubed, our depressed polynomial is an x squared plus 2x plus 4. Now, looking at this, I wonder if I can factor it again. But when I think about it, there aren't two numbers that multiply that would give me the 4 that would add together to give me 2. So this is not any further factorable. So our factors are going to be x squared plus 2x plus 4 times x minus 2. This tells us that one of our roots is x equals 2. Now, in order to find the factors of this, it could be 2 complex roots, it could be 2 real rational roots, or it could be 2 irrational real roots. So, the easiest way, of course, to do anything with a square is going to be to use the quadratic formula. So, I'm going to take a minute here and do the quadratic formula on the side. So you can tell at this point that our other factors are going to be complex roots, are going to be complex roots because we have an I. So we have 2 roots that are imaginary or complex, and then we have 1 root that is a real rational root. Simplifying this, we can divide each of the terms by 2 to give us negative 1 plus or minus I square root of 3. There's our other 2 terms, or 2 roots. So that's it, guys. Try some practice with it. I think Khan has some videos on it. They do not have practice. Be sure to pick up the handout. And next is our test review. So we're almost finished with the 3rd quarter. See you tomorrow at school.